Phoenix Learning Center. I'm Mr. B. During this lesson, I will explain everything that you need to know about binary ionic compounds. Ionic compounds are formed by the processes of oxidation and reduction. During oxidation, the atom of a metallic element will lose its valence electrons to form a positively charged ion, which is also called a cation, that will have a smaller radius than the original atom. During reduction, the electrons lost by the cation are simultaneously transferred to a non-metallic atom, causing its radius to increase. During reduction, electrons are gained by an atom or an ion, reducing its oxidation number, thus the term reduction. There are actually two classes of ionic compounds, which are also called salts, by the way. These are binary ionic compounds and ternary ionic compounds. Binary ionic compounds will contain the ion of a metallic element or cation and the ion of a non-metallic element or anion. Ternary ionic compounds will usually contain the ion of a metallic element or cation and a polyatomic ion. Since ternary ionic compounds possess a slightly more complex chemical structure, these compounds will be explained during a future lesson. In either case, the electrostatic attraction between the oppositely charged ions will cause them to come together to form what is called an ionic bond. The general properties of ionic compounds include a crystalline brittle structure. These compounds will also possess high melting points, and when dissolved in water or in aqueous solutions, these compounds will also conduct electricity, which makes them electrolytes. They will also conduct electricity when melted, which is also called molten or fused. Now for naming binary ionic compounds. When naming binary ionic compounds, use the name of the metallic element, then replace the INE ending of the nonmetallic element with IDE. For example, NaCl. Na is the ion of the metal sodium, and Cl is the ion of the non-metal chlorine. Therefore, the name of this compound will be sodium chloride. Other examples of binary ionic compounds include KBr, potassium bromide, CaI2, calcium iodide, and Li2O, lithium oxide. When writing formulas for binary ionic compounds, always refer to the periodic table. Write the symbols of the elements from the periodic table first. For example, the formula for sodium chloride will begin by writing NaCl. Now check the oxidation numbers on the periodic table. The oxidation number for Na is +1, and the oxidation number for chloride or chlorine, well, actually, chlorine contains multiple oxidation states, but in ionic compounds, always use the first oxidation number for the nonmetallic element. Therefore, the oxidation state of Cl will be -1. If the oxidation states cancel, the formula is complete. Clearly, +1 cancels -1, so the formula for sodium chloride is simply NaCl. If the oxidation numbers do not cancel, use the crisscross method. For example, lithium oxide. From the periodic table, the symbol for lithium is Li, and its oxidation state is +1. And the symbol for oxide or oxygen is O, and its oxidation state is -2. Clearly, +1 does not cancel -2. If the oxidation states do not cancel, use the crisscross method. Cross the oxidation numbers using the absolute value of the negative oxidation state. In this case, the negative oxidation state will be the -2 for oxide. Crossing over, we generate the following formula. Li2O. Remember, never cross over a 1 since the presence of O in the formula already indicates that there is 1 available. Now for Lewis dot structures of binary ionic compounds. Consider the binary ionic compound sodium chloride. The cation is always written first and is given no dots, but we'll do write in the oxidation state of +1. The anion will always be given an octet of dots of electrons placed within brackets, and the oxidation state is placed outside of the brackets. This represents the proper Lewis dot structure for the compound sodium chloride. Now for the compound magnesium fluoride, MgF2. In this case, there are 2 fluoride ions in the formula. Therefore, we must make a slight change in the Lewis structure. In this case, the proper way to write the Lewis structure is to place the cation in the center. So we place Mg+2 in the middle. And then we flank the Mg+2 with 2 fluoride ions, each possessing an octet of electrons within brackets and the oxidation state placed outside of the brackets. Remember, in a Lewis dot structure, the nonmetallic ion will always receive 8 dots, and the metallic ion will receive no dots. Other examples include NaI, sodium iodide, calcium bromide, CaBr2, and potassium chloride, KCl. Notice in each case, the metallic ion receives no dots, and the nonmetallic ions will receive an octet of dots. Now for some Regents practice. Consider the following. Which sample of matter has a crystalline structure? Well, we know that ionic compounds will always have a crystalline structure. Therefore, the answer to this question is number 3, NaCl solid. What occurs when potassium reacts with chlorine to form potassium chloride? Well, clearly, when metallic elements react with nonmetallic elements to form an ionic compounds, electrons are transferred and the bonding is ionic. Compared to distilled water, an aqueous salt solution has which of the following? Well, an aqueous salt solution will conduct electricity. Remember, aqueous ionic compounds are indeed electrolytes, so therefore they will conduct electricity. The answer to this question is 1. When lithium reacts with bromine to form the compound lithium bromide, LiBr, each lithium atom will do which of the following? Well, when ionic compounds are formed, the metallic element will always undergo oxidation, which means it loses its valence electron, forming a positively charged ion, also called a cation. The answer to this question is number 3. A sample of a substance has these characteristics: a high melting point, brittle and hard, good conductor, poor conductor of heat and electricity as a solid, and a good conductor of electricity as a liquid or an aqueous solution. Well, we just explained that as being an ionic compound. By the way, these questions all come from true Regents examinations. So if you can answer these questions properly, then you've got a good start to doing well on the Regents exam. Okay, this concludes my review of binary ionic compounds. Hopefully you found this lesson helpful. And remember, you may also visit my Facebook page at facebook.com/WPHS Chemistry. Thanks for watching.